Hello all, in this video I am going to discuss a problem on projection of straight lines. So this is the problem. Let me read the problem first. A straight line, capital AB, 100 mm long, has its lower end on HP and upper end on PP. The front view and top view measures 80 mm and 70 mm respectively. Draw its projection. So this is the problem. Okay, let's first locate the straight line as per the given conditions. So let's assume that this is the straight line of 100 mm long, and the question says the lower end is on HP. For instance, if this is the horizontal plane, so the lower end is on horizontal plane, something like this, and the upper end is on vertical plane. So the straight line, the final portion of the straight line is something like this. It touches like this. So you need to draw the projection when the front view measures 80 mm and the top view measures 100 mm. Okay, so if you see from the front view, so you will see a projected length less than 100 mm, obviously, because it's inclined, right? So we'll get less than 100 mm, so which is nothing but 80 mm in the question. So you need to position the angle such a way that it should measure 80 mm in the front view and 70 mm in the top view. Okay, so typically, so this is how a straight projection of straight line by rotating line method will look like. We have already discussed about this. Okay, so it's a similar problem, but the only difference is, so here it shows like the lower end is on HP, so that means the distance above HP, so that should be equal to 0. Okay, and the upper end is on BP, so that means, so one end in front of the distance, that should be equal to 0. Okay, so if you make this distance equal to 0 and this distance is equal to 0, what will happen? The locus of A dash will overlap with reference line, and locus of B will also merge with reference line. So in that case, what will happen? The reference line, the locus of A dash line and locus of B line will be same. Okay, so if I do that, what will happen? So you will get a projection something like this. Okay, see, for instance, so this point is B and this is, say, for instance, let's take B2. So this is B3 and this is B4, and let's take this as B2 dash, B3 dash, B4 dash, and this is B4, this is B2. What happened? So by doing that, so the sum of in front of distance and above distance will be equal to 0. So because of that, B2 and B2 dash, this length will become a point on the reference line, so something like this. Okay, and B1 and B3 dash, so that length will become a point, so that is nothing but B1, so that is mentioned here. And similarly, B4 and B4 dash will become a point, and that is nothing but this. Okay, so this will be the final position or the final orientation for this particular problem. Okay, so you need to remember one thing, because I always insist this: if you have a true length, you need to project and rotate to get the projected length, whereas if you have the reverse, that means if you have the projected length, you need to rotate and project to get the true length. Okay, so you need to remember this. Let's solve this problem. Let me draw the reference line first. So this is my X and this is my Y, vertical plane and horizontal plane. Okay, so the one end is on HP, so take any point. Okay, and this will be my A dash. Okay, because we are fixing this same, so I'm starting with the A dash, so that means I'm fixing this line. It means like what will happen in a same projector, the end A will be visible in the top view as well. Okay, so look at here, so A dash and A will fall always in the straight line. Okay, so what I'm going to do is, from here I'm going to extend a line something like this. Okay, because we don't know the position, but we know the A will be somewhere in this line. Okay. So next, we already know, right? So this get merged. So that means this will be my locus of A dash and locus of B. Okay. So now I'll ask one more question. Okay. So let's take this as the case. See, the line which is drawn in the red color, that is A dash to B dash. So that is nothing but your front view. I hope you know that, right? So I'll ask one more question. What is the length of A dash and B3 dash? So that will also be the front view length, okay? Because this front view is obtained by rotating this, okay? So then A dash and B3 dash will also be front view. So here B3 dash and B1 is getting merged in this particular problem. So that means A dash and B1 will be your front view. Okay. So this 2 points get merged. So that means B3 dash and B3 dash and B1 will be the same point. Okay. So that means A dash and B1 will be the front view. Okay. You mark a point here. So that will be my B1, and A dash and B1 length should be equal to the front view length, that is 18 mm. Okay. So I draw on this. Next, what I need to do is, so I know the front view length. So what will happen? So to get the orientation of the front view, I used to rotate, right? Something like this. I'll rotate. So somewhere in this arc, the front view, that is B dash will be there. Okay. Next. So next, what we need to do is we need to locate the point here. Okay. So we have located B1 here. So what is the distance between A and B1? So that's the true length. So we know one end, and we know the other end will fall somewhere in this vertical line. So take a compass. Take a compass and measure 100 mm, keeping B1 as the center. You make an arc. You will get something like this. Okay. So this point is nothing but my A. So once you located the A, what will happen? So you will get the locus of A. So this will be my locus of A. Okay. So I identified the third locus as well. Okay. So I know A and I know the top view length. So with that, what I can do? So I can directly plot my top view. Okay. So something like this I can plot. Okay. So by doing this, I will get the top view. So here for this. Okay. And this will be my B. And this will be my true length in the top view. So I have completed the lower part of the problem. Okay. So I have the top view. Okay. So I need to get the true length in the front view. How I can do? So I have the projector length. So first what I need to do is I need to rotate the projector length something like this. After doing that, after rotating it, I need to project. So I am starting from locus of A. So that means I need to project it till locus of B dash. So locus of B dash is not known. So I need to project arbitrarily to some length. Something like this. So I need to arbitrarily project something like this. But what we know is, we know the true length. And we know one end, and we also know the other end will fall somewhere in this vertical line. So what I can do is take a compass, measure 100 mm, keeping A dash as the center, make an arc, something like this. So if you do that, you will get true length in the front view. So once you get the true length in the front view, which is nothing but B1 dash, so you can make a horizontal line to get the locus. So I made the locus. So this is nothing but locus of B dash. Okay. So that locus of B dash line will cut somewhere in the arc drawn from the true length in the top view. So that arc will intersect in the locus of B dash. So that is nothing but my B dash. Okay. If you connect the B dash and A dash, you will get the front view. Okay. So finally, if you draw a vertical line from the other end of the front view, that will fall straight line with the other end in the top view. Okay. So this is how you need to draw. This is how you need to solve this particular problem. Okay. Next you need to dimension 6 things. One is the front view length, the top view length, then true length, then theta, alpha, phi, beta. See, I have 4 angles, so you need to mention theta, alpha, phi and beta. So you need to mention this. Okay. So you need to measure the angles with the help of protractor, and you need to write it here, and you need to measure the, you know, the length already because it's given in the question. The front view length is 80, the top view length is 70, the true length is 100, and you need to measure the angle and write it here. Okay. So thank you.